The man behind the book, Johann Friedrich Gülich. If you ever sat with a stack of technical papers, wrestling with why an impeller cavitates at part load, or why a pump vibrates at a frequency nobody can explain, there's a good chance you eventually reach for one book. Almost 1,000 pages. Dense, precise, sometimes intimidating. Centrifugal Pumps by Johann Friedrich Gülich. For engineers like me, and maybe like you, this book isn't just a reference. It feels closer to a second education. But most of us who've used it for years never really stopped to ask a simple question. Who was the engineer behind it? Today, we start there. Welcome to Pump Design Lab. This is the story of J.F. Gülich. Section 1. A German Engineer in the Making. Our story begins in Germany in 1939, a year the world remembers for very different reasons. Johann Friedrich Gülich grew up in a country rebuilding itself, in an era where engineering wasn't just a career path. It was one of the few ways to bring order and logic to a broken world. He went on to study mechanical engineering at the Technical University of Hannover, earning his master's degree there. Then he pushed further, completing a PhD at the Technical University of Darmstadt, one of Germany's respected engineering schools, the kind of place that shapes generations of designers and machine builders. By the time he stepped into his first job, Gülich wasn't just trained. He was forged in a tradition of engineering that prizes rigor over shortcuts and depth over convenience. And his first real job would test that rigor immediately, because it wasn't in pumps at all. It was in nuclear power. Section 2. The Nuclear Years. Gülich's career began at Siemens in Erlangen, in the nuclear power plant division. Think about the industry at that time, the 1960s. Nuclear power was a frontier of engineering. High stakes, unforgiving tolerances, and systems where failure was simply not acceptable. It was in this world of extreme precision that Gülich cut his teeth. Then, in 1966, he made a move that would quietly define the rest of his career. He joined Sulzer in Winterthur, Switzerland, one of Europe's classic industrial names, with deep roots in pumps, turbines, and heavy engineering. But again, he didn't walk straight into a pump department. He started in nuclear as a development engineer, working on reactor-related design. For around a decade, he led Sulzer's thermohydraulics work, the thermal and hydraulic design of steam generators and heat exchangers for nuclear power stations. 10 years of steam, heat transfer, and flow behavior under extreme thermal loads. It's easy to skip past that part, but we shouldn't. Because much of what Gülich later wrote about cavitation, pressure pulsations, and flow-induced vibration in pumps is built on this decade of watching fluids under punishing thermal and hydraulic stress. He didn't begin as a pump specialist. He became one after mastering something even more demanding. Section 3. Finding his life's work. Eventually, Gülich's path turned toward centrifugal pumps, and this is where most pump engineers first meet his name. At Sulzer, he became responsible for the hydraulic development of centrifugal pumps and for parts of their mechanical development as well. That meant he wasn't just solving flow problems on paper. He was living inside the full life cycle of pump design, hydraulic performance, mechanical integrity, vibration, wear, fatigue, the complete machine, not just one slice of it. Most engineers spend their lives inside a single lane, hydraulics or mechanical design or reliability. Gülich moved across all of them at one of the world's demanding pump manufacturers for decades. Over time, he wasn't only designing pumps. He was accumulating something rarer, pattern recognition. He'd seen failures other engineers knew only from case studies. He'd dealt with problems that, at the time, had no ready textbook answer. At some point, that kind of experience needs to be written down. Section 4. Distilling a career into one book. Gülich retired from Sulzer around 2001, but retirement, for a mind like his, didn't mean stepping away from pumps. It meant stepping into a different role, independent consultant. Somewhere in that transition, decades of hydraulic development, nuclear thermohydraulics, mechanical design, patents, and journal publications were distilled into one work, Centrifugal Pumps. If you've held this book, you know it isn't a light introduction. It reads like the accumulated memory of an entire industry. Cavitation and its damage mechanisms, numerical flow calculations, hydraulic forces, pressure pulsations, noise, bearing housing vibration diagnostics, pipe vibrations, pumping of viscous liquids and gas-liquid mixtures, hydroabrasive wear, fatigue damage in impellers and diffusers, material selection under corrosion and erosion, pump selection, and hydraulic quality. This isn't the voice of someone summarizing what they've read. It's the voice of someone who has chased these failures on real machines for real customers over more than 30 years. There's also a human detail behind the scenes. The widely used English edition exists through a careful translation and review process, closely overseen by Gülich himself from Switzerland. Even the act of sharing this knowledge with the wider engineering world was deliberate and cared for. It tells you something important. Precision wasn't just his professional style, it was how he approached everything. Section 5. Why this matters to US today. So why does any of this matter if you're a design engineer sitting in Houston or Stuttgart or Perth staring at a pump drawing right now? Because Gülich's career is a reminder of something easy to forget in an industry obsessed with speed. Deep expertise is built slowly across disciplines over years. Nuclear, thermal, hydraulic, mechanical, before it ever turns into the reference everyone quotes. Every time we talk about cavitation margins, interpret vibration signature, or debate impeller trim and part load behavior, we're standing on top of the accumulated judgment of lives like his. That's not just trivia. This channel, Pump Design Lab, exists because that same body of knowledge deserves to be unpacked, explained, and made practical for engineers working today. Not just referenced. Understood. In the videos ahead, we're going to take the key phenomena that pump designers wrestle with: cavitation, hydraulic forces, performance curves, vibration, failure modes, and break them down piece by piece, in the language of engineers actually doing the work. If that sounds useful to you, subscribe, and join me as we explore centrifugal pump design from fundamentals through real-world problems. Welcome to Pump Design Lab. I'll see you in the next one.